Alright, so welcome back, math fans. This is Mr. Hunter again. So, again, we're back in antiderivatives, but we have antiderivatives with a particular solution. Solution. So basically what we're going to do is we're going to find the antiderivative just like we did on the other page. We're going to have a c. Alright, but then they give us a point. So like number one, they give us a point right here. This is a point on the antiderivative function. So we'll plug in an x, and we'll plug in a y, and solve for c to get our y-intercept. Okay, so let's start here. Y equals the integration of the integral of 3x squared minus 1 dx. Alright, so remember you up the exponent by 1 and you divide the coefficient by that. So that would be y equals 2 plus 1 is 3, 3 divided by 3 is 1, so that's x cubed. Alright, this is an x to the 0 right there. So x to the 0 plus 1 is x. Negative 1 divided by 1 is negative x plus c. So basically, if you have just a constant floating out here, it's going to stay there, but you're going to add an x to it. That's the bottom line of it. All right, so then they gave us a point. This point right here. So x is 2, y is 4, so plug everything in. Y is 4 plus, not 4 plus, what am I doing? 4 equals 2 to the third minus 2 plus c. That is 4 minus 8 plus 2, that's c equals, negative 2? 4, 5, 6 minus 8 is negative 2. So I know c is negative 2. Therefore, my final answer would be y equals x cubed minus x minus 2. That would be your final solution. Okay? Now again, if we did not give you this point, you would stop right here. Since we gave you that point, you plug it in and you can find that bad boy. All right? So number 2. You might be able to do this one on your own. Maybe not. What else? Find the particular solution of this. So f prime equals that. So therefore, f of x would equal the antiderivative of, I'm going to do 3x to the negative 4 because it is so much easier to deal with negative exponents in calculus than it is to deal with fractions, x in the denominator. Wow, I told you that Mrs. Hunter is better than I am. All right, so again, raise the exponent by 1 and divide the coefficient by that. That means f, capital F of x, is going to equal, divided by negative 3, negative x to the negative 3 plus a c. Okay? And we're going to plug in our 1, 2 up here. So 2 is y, so that's 2 is our f of x equals negative 1 to the negative third plus c. That is the most ridiculous thing I've ever seen. What is negative 1 divided by 1 to the third? That's negative 1 added over here, so that's plus 1. So c equals 3. This is like... this is like just messing with your head. You're evil. So c equals 3. Therefore, f of x equals negative x to the negative third plus 3.
Would you rather me give them 64?
No, I would rather them not give you 64, but we could do 4. If that was a 4, so that's negative 1 over 4 cubed, that would be accurate. That would be ugly. But you're right. That's ridiculous. All right, so here we go. Let's do the last one. Oops, why did I do that? Last one on the page. This one asks us to... The acceleration of a particle moving along the x-axis is a time t. Is given by the acceleration. Okay, so this is a physics question. So first things first. One quick thing. If I have a position function, real fast. Oh, give me a pen. Why is it? Pause. I think I just broke it. There we go. If I have a position function where x is position, y is a... it is paused. How far back is it paused? No, it's still recording, see? See the timer down there? It's still recording. My wife thought it was paused.
Sorry.
All right. So if I have a position function, I can take. So let's say that's f of x. Helps if I have an actual f of x.
You're not very good at this, are you?
Shut up. F prime of x would be the velocity function. F double prime of x would be the acceleration. And then the last point would be F triple prime would be, is it jerk?
Yeah.
Yeah, that would be jerk. Think of that as like g-force. All right? So what we've got here is we're given an acceleration, and then they say give us a velocity point, and then they give us a position point. Find the equation for the position. So what we're going to have to do is find the antiderivative of this, plug in the point, then find the antiderivative of that, and plug in that point. Yes. So here we go. A of t. Helps if I have an actual pen. Battery power at 15%. I don't care. It'll last long enough. A of t equals... Well, no. I won't do that. The velocity at time is going to equal the antiderivative of 6t minus 2 dt. And if you're not already putting serifs on your t's like this, you probably should start. Otherwise, you're going to get really lost really quick. So the velocity at any given time is going to equal 3t squared minus 2t plus a constant c. All right, and they said the velocity is 25 at time 3. So we can plug that in. 25 equals 3 times 3 squared minus 2, 3 plus c. So that's 25. 3 times 3 is 9 times 3 is 27. So I'll subtract 27. 2 times 3 is 6. That's negative 6 plus 6. So that's what? Negative 2 plus 6 is 4. 4 equals c. So velocity at time t would equal 3t squared. This thing is driving me crazy. There we go. 3t squared minus 2t. Oh, that's much better. Plus 4. So that's the velocity. All right, but we want the position. So the position at any given time would be the integration of equals. Forgot my equal sign. I pulled one of my own students playing. Dropped my equal sign. 3t squared minus 2t plus 4 dt. Okay? And I'm being told by the master that I'm supposed to put parentheses around all that, which probably means the same thing up here as well as other places as well. I apologize. So, position to time t would equal 2 up to 3, so that's t cubed minus t squared plus 4t plus c. My constant c. So, let's go back and find that point. Position 10 when t is 1. So at time 1, position is 10. So, position is 10 at time 1 to the third minus 1 squared plus 4 times 1 plus c. So I'm going to subtract 1, add 1, subtract 4. So that's 10 minus 5 is 5 plus 1 is 6. So c equals 6.
That's such a kooky way of doing it.
Miss Hunter doesn't like the way I'm doing this.
Why don't you combine like terms and then it'll just work out?
You're right, I could combine like terms. Okay, I'll combine like terms. I just did, this is 1, so I subtracted 1. This is negative 1, so I added 1. This is 4, so I subtract 4.
You do it so much harder. 1 minus 1 cancels. You just had to do 10 minus 4, which is 6.
Whatever. Anyways, so the time at position the position at time t equals t cubed minus t squared plus 4t plus 6. And Miss Hunter can tell you all about why this is wrong on Thursday. Wednesday. I thought y'all had flex days on Wednesday.
No, we have a 4-day week this coming week.
Okay, whatever. Just found out a way that I'm wrong. All right, let's do the next page. Okay, back to it. So, yeah, the introduction of trigonometric functions. Yeah, you're just gonna have to memorize these. I'm sorry. There's no ifs, ands, or buts around it. The integration of cosine of x is sine x plus c. The integration of the antiderivative, I'm sorry, Miss Hunter, the antiderivative of sine x is negative cosine. So these kind of circle on each other. But remember, when you take the antiderivative of sine, you get the negative cosine. Okay?
So, remember we did... Oh gosh, I can't do this.
All right, and secant squared is going to be tangent. These ones you're just going to have secant times tangent is secant plus c. Cosecant squared is negative cotangent. Cosecant cotangent is negative cosecant. You just gotta have to remember these. All right.
So this one, remind them of the Santa Claus.
The Santa Claus?
Yeah, tell them about Santa Claus.
The Santa Claus? Okay. I am totally lost. There's a Santa Claus rule.
So there's a positive Santa Claus and there's a negative Santa Claus. Derivatives go this way. Antiderivatives go this way.
Oh, okay. Santa Claus, Santa Claus. Okay, that's true. Derivatives go that way, antiderivatives go that way. Nope, she's absolutely right. There is a Santa Claus rule. All right, and coefficients. All right, essentially coefficients, you can treat them as if they were out front. So 2 sine x dx. You can treat it as if it is out front. All right, there's nothing to do with that. So the antiderivative of 2 sine x would be negative cosine x, right? Yeah. I'm just telling y'all have to remember this. So that would be negative 2 cosine of x plus c. So we'll call that, if that's y prime, that would be y.
No, that's not y prime. That's just regular y.
Okay, whatever.
No, it makes a difference. Also, I mean, whatever.
I'm sure it makes a difference, sweetie. All right. Secant and cosecant. I got to go back here and look at these. So secant squared is tangent. Cosecant squared is negative cotangent. So secant squared is tangent. So that would be pi. Helps if I have a marker.
You can just do equals.
Pi. Oh, you want me to just do equals over here?
You just do equals.
Okay, equals pi tangent theta. I don't have enough room to do that. Pi tangent theta plus, because remember cosecant is negative cotangent, so cosecant, so that's cotangent theta plus c. And yes, this one has a plus c, and that one has a plus c. That does not mean it's plus 2c. It is plus a single c. That's okay. Because, oh, you forgot your parentheses. Because it's like that.
Equal sign.
Equals this. Equals that right there. Cool? All right, we'll keep going. I have no idea what she's asking me to do at this point. All right, this one's a boatload of fun. So again, first things first, we'll do you got the integration of 3t squared, so that's a normal, minus secant t tangent t plus, hey, question, what is sine of pi over 2? Oh yeah, that's 1. All of that dt. So, if you can turn something like this, if you know what the angle is that you're dealing with, and you know it turns into a 1 or a 1/2 or something like that, go ahead and do it. It makes life infinitely easier. Okay? So, and actually, because there's no variable in there, this is a constant anyways. So all you would do is sine pi and you shove a t on the end of it. All right? Don't tell Mrs. Hunter that you can just shove a variable on the end of it. She's going to get really mad at you for that. I really hope they heard that. So again, 2 plus 1 is 3. That's t cubed. She just told me she was going to shove a variable up my butt. Secant t, tangent t. I got to go look at that. Oh my gosh, I can't think anymore. Secant tangent is secant x. So that would be minus secant x?
Yeah.
Yeah, secant, so secant t. well, it's x up there, it's t down there, plus t plus a constant. And again, this is why you need to start putting serifs on your t's. Because where does the t stop in the plus t? Especially if you have a dt. Just wait until you do stuff like dy dt. That just gets crazy. Last but not least, this one. If the second derivative of f is given by that, what is the following? Could be this one. Okay, so because we're doing two antiderivatives, and we don't have the point for this first antiderivative, we can't go all the way on our own. But we can go halfway and make a suggestion beyond that. So if I were to take the antiderivative of 2x minus cosine of x dx, that would equal x squared plus sine, right? Negative cosine of x. I just totally lost myself. Cosine of x goes to sine of x. Nope, that's right. It's negative sine still. I forgot where my negative goes. Negative sine of x plus a c. All right, so I can already go ahead and say, well, that one's out and that one's out. Because this guy is going to turn back into a cosine. This is going to turn back into a cosine. It's going to turn into a positive cosine. All right. So that cancels that one out. And this guy up here, if I raise that 2 to the third power and divide it by 3, so that becomes 2x to the third power divided by 3, I can tell you right now, this one right here isn't working. So this is a plausible second antiderivative of f double prime. All right. The only thing we don't know is if those are correct or not because we don't have points for the first antiderivative as well as the second antiderivative. Cool. Have fun.